Hi, I'm John Moore from ETTER Engineering. One of the things we specialize in, besides combustion systems, are fuel handling systems for industrial and process heat. What you see standing behind me is a fuel system for 167 million BTU an hour lime kiln burner. This system takes gas from an intermediate station being delivered at 45 psi and takes that gas and breaks it down into 3 separate trains. Each one of those trains serve a separate function, and we're going to talk about the whole system today. This is where the gas supply will come in from the intermediate station. It enters our system through a lubricated plug cock that's used to manually turn off the gas to the entire valve rack here. We then have a main inline gas strainer. Its purpose is to take out all the debris. We also have a mud line for any condensate that may collect. And the unit can be blown down from time to time to clean out the strainer. It's difficult for you to see, but behind these instruments here, we then go into a metering run. This unit right here is a Census turbine meter that we're measuring gas flow to each station from. We're also reporting this back to the regulating and heating station as an interlock to tell us whether or not we've got sufficient gas flow on that system to put heat into the gas. Continuing on, we then have a pilot actuated gas regulator that's taking the 45 psi supply from the intermediate station and dropping it down to the high 20s, 26, 27 psi that we're using to feed the whole system. These are the sensing lines and control lines for the pilot actuated regulator. Okay, so let's come around the corner here to the manifold. So we're coming off the regulator up here and coming down into this manifold system. This is a pressure relief valve that we're using to make sure that we don't overpressurize any of these 3 valve trains. The valve trains that we have a main gas valve train, what is called a starter gas valve train, which will act as a very large pilot to both ignite the main gas and also act as a when instead of shutting down the entire burner, they can go into a standby mode and use the starter gas as standby gas. The burner input is 167 million BTUs. So this starter gas is about 3.5 million BTUs, and we're lighting it with a 1 million BTU an hour pilot. So let's go over each of the 3 valve trains separately. But like I said, here's the manifold that comes down, feeds those. We have a drip leg with a valve at the bottom for blowdown. We have a pressure gauge here to monitor our set point of the pilot actuated regulator. Okay, let's come around the side. And what we've got now is the igniter gas coming off the front, comes through. We have a manual ball valve for isolation. We have our own regulator here as a second stage regulator. This gives us independent pressure settings of all 3 trains. We then come into this valve right here. This valve is a 3-way valve that's going to provide the facility with the ability of going with a pilot with propane that they're going to hook up on site. So this valve is got a locking handle, and as you can see, we've now just put it in propane position. The gas will come in from the rear. This is green, meaning the feed is that way, and the red here is indicating that we've blocked out the natural gas. If you zoom in here, notice as I rotate this valve, we now go green, green here, and red over here, which means we now have natural gas supply. We then come into the inlet of our first safety shutoff valve. We've got a glycerin-filled gas pressure regulator, so we know what pressure is being introduced to the train. We've got a double block and bleed. Here are the 2 blocks. The bleed valve is right back there with the ASCO valve. We're using Maxon valves as our safety shutoff valves, and we have a manual lockable ball valve on the vent line. Continuing on, we exit out. We've got a final gas pressure reading that we're providing to the igniter train, and we have a manual ball valve to again isolate the flow. Then the gas feed will go up to the burner. The burner is actually overhead. The burner is about 20 feet long and probably 15 feet in the air. Okay, so now let's talk about the starter gas, or what is also called the standby gas. It will be the large pilot that ignites itself off the ignition train, okay? We come off the same manifold that's feeding all three trains. Again, similarly, we have an inlet valve, manual ball valve for turning on and off the gas supply to that train. We then go through a high pressure census regulator, which is going to allow us to set the gas pressure to this train at, I believe it was 7 psi is what's needed. We can set our regulator using that pressure gauge. And again, our pressure then comes into a device that you're going to have a hard time seeing from there. But this device right here, which looks exactly like this device in my hand, but it's just on the other train, is a Rosemont smart pressure transmitter that's working with a controller that is also being used as the low gas pressure switch to the train, okay? And that's located right at the inlet to the first of the two safety shutoff valves. Again, we have a Maxon valve back here in the back, okay, on this train, and an ASCO valve and a manual vent valve in the back for this train. And then the second Maxon safety shutoff valve for our double block and bleed system. So this Maxon, that Maxon, and that vent valve create the double block and bleed. Then coming around this side, again we have a Rosemont smart pressure transmitter that is acting as the high gas pressure switch for the train. It's this blue device, and it's wired up to each one of those Rosemont controllers, Rosemont transmitters, excuse me, have a their own individual controller that is not only going to read out what the pressure is, but also communicate to the burner management system exactly what the pressure is. Finishing up, we have an outlet pressure gauge, and then finally a manual ball valve that we can isolate the flow to the burner. Again, this is going to be about 3 million BTUs at about 7 psi. So now let's talk about the main gas train. Once again, the manifold supply right here, feeding all three trains. Here out of the middle, we have our takeoff for our main gas train. This train is going to be 167 million BTUs, as we discussed. We start off with a manual lubricated plug cock, again, to be able to isolate just this one train from the rest of the system. We come in, we've got our pressure gauge here with a petcock, and we have our low gas pressure switch that is being done through the Rosemont smart pressure transmitter connected to one of the controllers above, okay? This will feed back the supply pressure from the main regulator here to the burner management and assure that we do not have too low a pressure and trip the system out. We then feed the inlet to our double block and bleed again, this time being done with two Maxon 5000 safety shutoff valves, and the red valve in the back is an STOA Maxon vent valve. We also have a manual lockable vent valve in the back that will normally be locked open, okay, and can be closed and locked closed for service reasons. One of the things that you can't see in any of these would be On each one of the Maxon safety shutoff valves, we do have a leak test valve. It's around back, coming off the back of the body, and it's there to provide leak test capabilities when you're doing a safety audit on your gas combustion system. So double block and bleed. Now we run into our high gas pressure switch. Again, the Rosemont smart pressure transmitter reporting to one of the controllers above. Its job is to make sure that the gas pressure that we're feeding this flow control valve is of the proper range and not too high so that we would overfire the burner. It so happens the burner management system that we are connecting this to is going to be a fully metered combustion control system, so it will be going on mass base rather than just position base, and therefore it's not quite so critical, but still NFPA requires a high gas pressure switch monitoring the supply pressure to the flow control valve. This valve is a pneumatically actuated, electrically controlled with a 4 to 20 milliamp input signal, okay? But it is pneumatically actuated on the valve body itself. So over here we have a smart I to P transducer that's going to take the electronic 4 to 20 milliamp input signal from the combustion controls and change that to a pneumatic signal controlling the pneumatic flow control valve. We've got a valve position indicator and low fire start switch that is also with the flow control valve. So we come out of the flow control valve right here and we feed up to the burner. We have our own pressure gauge here for monitoring what our adjusted pressure is out of the flow control valve, and we go up through our lubricated plug cock to the burner that would be roughly 20 feet in the air. That concludes talking about the valve componentry, and now we're just going to walk you through briefly the electronic side of this and the wiring to the junction box. All the electrical components of all three valve trains and the main valve system across the top header all come back to this junction box here for a single point interface for wiring. So I'm going to open that up for you. What we have here is basically terminals for all the various components. We have, you know, the wiring diagram for the guy out in the field on how to wire it up. But the additional componentry that we have in here, this is an intrinsic safety barrier, which is acting as a safety to ensure that the electronics that we wire back up to our gas meter that has a slot sensor in it, that we can't send any spark or any arcing or any electricity back into the gas line. This device here is hooked up to that flow meter and is being used as a minimum flow switch to tell our regulating heating station whether or not we've got sufficient flow. Everything else is basically just all the points of wiring that are necessary to go to the burner management and combustion control system, and that'll all be wired out in the field at the job site. Well, thank you very much for joining us today, and I appreciate your time. Just please remember, at ETTER Engineering, we can help you out with all your fuel handling systems. Whether you're talking about a 1 to 2 million BTU an hour gas train, which is something we build several times every day, to a complete, very sophisticated, custom engineered and designed fuel handling system for a pulp and paper mill, such as what you see behind us and we've just walked through. We have a full gamut of offering, and we can take care of your needs, whether they be very small or very large. Once again, thank you for your time.